Hey everybody, Ms. Dietrich here. We're going to take a look at question number 7. And I have to admit, I'm not a fan of how this is worded because you really have to stop and think about it in order to know what they're talking about. But we'll try to break it down for you. Liam buys 3 identical plastic containers that are right rectangular prisms. One face of each container measures 4.5 by 2 inches. So I have that represented here as like being the floor of the thing. The total volume of the 3 containers is 135 cubic inches. How many of these containers can Liam set on a shelf that is 24 inches long with the 4.5 inch by 2 inch faces touching? All right, so first of all, if we know that 3 of the containers would be 135 cubic inches, then that means that one of the containers, if we divide that by 3, one of the containers would be 45 cubic inches. So let's figure out this missing dimension that we don't know by taking advantage of the fact that we know the volume of one of them, and we know the length of one of them, and we know the width of one of them. So let's apply that to the formula. So the formula is volume equals length times width times height. We'll slip in our 45 cubic inches here. The length is 4.5. We'll use the decimal equivalent. Times the width, we'll put in 2, and then we'll put in the variable h for height. Next, simplify this, and if we simplify that, 4.5 times 2 ends up giving us 9. So now the next step is to apply algebra to figure out the height of the thing. So what's the opposite of multiplying by 9? It would be to divide by 9. All right, and then if we simplify here, that equals 1, and 1 times h is h. And then this divided by this would give us 5. All right, so let's put the 5 here. So now we know that that's 5. All right, now when we think about if we're going to line them up, right, how many of these containers can Liam set on a shelf that is 24 inches long? So the thing that's confusing about this is you have to think about, well, what's the orientation of these things? Are we going to do, lay them, is the shelf going to be like this, like picture the shelf going across? Or are we going to lay them this way? Well, if you read it carefully, the way that we're arranging it is we're arranging it like this. So picture the shelf, and this is kind of like a side view here. Picture the shelf. So I'm drawing the shelf here in green, sticking out of the wall, and we're arranging them like this. So that means that what's going to go, because if you think about it, this face right here, right? What we were calling the floor of the thing, that's what has to be touching, because it says here those faces are touching. So that means that if they're touching, let's put the dimensions here. This is 4.5 going this way, right? And 2 going this way, right? So let me use different colors to help you understand. So that's 2 going that way, and it's 4.5 going this way, and that's what's touching each other. So the height, we know is 5, right? The height we know is 5. So that's really now, that's the dimension that's now, when you turn the thing on its side, that's this number right here. So if that's 5, and this is 5, and this is 5, so far we're up to 15, right? And this is 5, so far we're up to 20, right? 5 times 4 is 20. Can we fit an extra one? If we clone that, can we fit one more? Because now we're going to be up to 25. That's not going to fit, right? It's going to overhang the shelf. So it looks like we're not going to split it in half. We're not doing a half of one. We don't want the thing to fall off because it's on the edge. So count up how many are there. See, count up how many are here, because we need 20 inches if we put 4 on. We need 25 inches if we put that 5th one on. And we don't have 25 inches. They're telling us that it's 24 inches. So that means we're going to not put that on the shelf so we don't have a catastrophe on our hands.